Hello, everyone. I am Neeraj Singh, Assistant Professor, Department of Physics, Rajki Mahavidyalaya, Modi Nagar, Ghaziabad. Uh, Today I am going to present basics in interferometry of light. So basically, what is light? For many centuries, light is considered a stream of particles, but we know that light wave exhibits various behaviors which cannot interpreted through the particle theory of light, such as refraction, diffraction, and interference, etc. In 19th century, the particles concept was replaced by the wave theory. Basically, we would say that the light having both nature, because we know that still there are few phenomena in physics which cannot be explained by the wave nature of light also. For example, photoelectric effect, Compton effect, black body radiation, etc. So in today's era, या आज के समय में we would say that light having both nature, wave as well as particle nature. It is also a well-known fact that light waves are transverse in nature, with, having two components, magnetic and electric field, each one of them oscillating perpendicular to the other and to the propagation of a direction. Today we will focus what is interference. So basically, whenever waves superimpose and combine, we will get a bright and dark region. Bright region is known as constructive region, and dark region is known as destructive region. I have shown these pictures, which I have extracted from internet, and interference in nature and daily life also. It is very obvious that I have shown this image: soap bubbles, island water, peacock feathers, etc. So there are so many phenomena which we can feel in nature and daily life. So first thing is, what is necessary conditions for interference? Because we know that this dark and bright pattern we cannot see for each and every sources. So basically, it exploits the phenomenon of light wave interference, where under certain conditions, a pattern of dark and light bars called interference fringes can be produced. So what is these certain conditions basically? So my answer is, these certain conditions, there is one word, this is coherence. So what is coherence? Coherence of light wave is defined as the correlation between the electric field values at different locations or times. The coherent light source is able to produce coherent waves for interference. Ideal coherent source is a source with one wavelength which does not exist in practice. It means ideal coherent wave is also does not exist in practice. Practically, there is no fully coherent light or fully incoherent light, but there are light sources with different degree of coherence. Normal light sources in general, mm, uh, we would say that are incoherent in nature. So there are two types of coherence, spatial and temporal coherence. So what is spatial coherence and temporal coherence? I have shown this figure. Uh, this S is light source, and I have shown this x1, x2, and x3. There are 3 points. So what is spatial coherence? So the degree of correlation between different points on the same wavefront at the same time. So what is spatial coherence? The degree of correlation between x1 and x3, because these points are at the same wavefront. It is also notice that spatial coherence is light source dependent, As the source size extends, the degree of spatial coherence decreases. So, what is temporal coherence? So, the correlation between the electric fields at the same point but at different times. Here, I have shown these points x1 and x2. So, the temporal coherence proportionate to the wave train length. Monochromatic source such as laser have a high degree of temporal coherence. So today's we would say that lasers are coherent sources. So in a previous slide, it is very clear from the discussion that the normal sources not are not in general coherent sources. So to get interference fringes, first thing is how to create coherent sources. So there are in general two ways to create coherent sources. First one is by division of wavefront, and the other one is by division of amplitude. So by division of wavefront, there are I have taken few examples. It's a very well-known uh, example is Young's double slit experiment. Other one is Fresnel by prism. Third one is Lloyd mirror. I have shown the Young's double slit experiment here. This is a light source here, and in front of this, I have taken this single slit, and in front of this, from a certain distance, I have taken two slits here, and when light emerging from this light source and passed out from these two light slits S1 and S2, we will get a beautiful interference fringes into the screen, as I have shown here, maxima, minima, etc. It means dark bright in general. And these S1 and S2 is like a two coherent sources with each other. Light emerging from S1 and S2 mm, will give us this interference pattern. So in this way, we will also uh, create two coherent sources by Fresnel by prism and Lloyd mirror also. So next one is the coherent sources created by division of amplitude. So I have taken few examples. This is a very well-known example. Is a thin film pattern, thin film interferometry. Other one is Newton's ring and Michelson interferometer. I have shown basic diagram for Michelson interferometer. Basically, in thin film, in daily life also, in rainy day, we would see uh, in roads uh, a colorful pattern when oil uh, drop is fell into a water, and there is a thin film on water, and we will get a colorful pattern when sunlight uh, incident into this film. And in the same way, in others, we would say in natural phenomena also, and a thin film interferometer is a very well known and interesting, and we can feel in daily life also. Newton's ring experiment is a very we will get a beautiful circular fringes. But here I have showed Michelson interferometer diagram. So this is a monochromatic light source, and this is a basically semi-reflecting surface from which when light incident from this monochromatic light source, 50% light, almost 50% light is reflected uh, towards fixed mirror M2, and 50 almost 50% light transmitted to this movable mirror M1, because there are two arms here. One is M1 arms and M2 arms, and after reflection from mirror M1 and M2, uh, it is detector here also, and we will basically receives light from M1 and M2, and we will get very beautiful fringes, circular fringes, whenever these mirrors M1 and M2 are perpendicular with each other. Uh, there is one difference between fringes of Newton's ring fringes and Michelson interferometer. Basically, we will get circular fringes, but in Newton's ring, the fringes are known as fringes of equal thickness, and in Michelson interferometer, the fringes are known as fringes of equal inclination. So, thank you very much. This is a basic idea about um, interferometry.